Hello, my name is Lolita Dera, and this is Physics 2212 Lab 2, which is the comeback of the charge tapes. So, for the contents of this lab, we're going to go through the introduction, then the experiment, and then we're going to go through a computational model on GlowScript. Then we're going to do some calculations, analysis, and then answer some questions at the end. So if you remember in the last lab, we worked on observing charge tapes and modeling them as point charges at the center of the tape, and this time we're going to do a more accurate model by making line charges across the tape, and that will achieve this result using superposition principles. The key ideas at play are Newton's second law and the Coulomb's law, and the results that we got are that the electric force on each tape is about 1.46 times 10 to the negative 3 coulombs, and the gravitational force about 1.47 times 10 to the negative 3 newtons. So the initial conditions are as follows, and we use the guiding formulas of the electric force and these constants right here, as you can see. And we're modeling this as line charges on two tapes that are repelling each other as they are equally charged. So these are the steps of the experiment. They're the same as last time. We're setting up a table with some tape pieces, marking them accordingly, and measuring them. Then we're going to hold the charge tapes together and see if they attract or repel. So just going through the experiment really quick. And as you can see, the tape is clinging, so we know that it's charged. And this is the behavior of the tape. So now onto the computational model in GlowScript. So as you can see here, the gravity force and the charge are the same, and we go down the mass, if we go back here, the mass, length, distance, and the charge. The charge is taken from the previous lab, and then we're multiplying by a factor to make it equal to the gravitational force. Going down, all of these are constant and used to model, but this function right here is for the observation location and finding the charged particle as a function of the r vector, which is the distance, and making a line charge out of that. And this is the rest of the code. If we run the program, these are the results that we get. So for the calculations, the force of gravity is as follows. So we have 1.5 times 10 to negative 4, which is our mass times the gravity, and we get the same answer as we showed in the beginning, and also as shown by our code. The electric force Q is shown by this formula, which is the square root of mass times gravity times 4 pi epsilon naught, which is the permittivity of free space. This is the number there. And we also have the value for that as a result of the calculations. It's a little bit off from our computational model, but that's probably due to experimental error. There can also be possible error from the loss of charge after handling the tape, so we don't really know the value there. So the analysis. This time we assumed instead of that the tape is a point charge, that it has charge evenly distributed. So for this experiment, we modeled it as a line charge. Both U tapes had the same amount of charge is another assumption. We're also ignoring the air resistance on the tape. This might be wrong because the charges may not exactly be the same, and the lengths of the tapes may differ marginally even though they're pretty fairly evenly distributed. The air resistance is not a negligible force, even though we're treating it as one, because the tape has a high drag, but for the sake of this experiment, we are going to say that it's negligible. And so, for the what if and the why questions, if you had modeled each of your tapes as a single point charge like the previous lab, compare the estimated value of the charge, and why do these estimates differ? So for the answers, with a single point charge, the margin of error can be pretty big depending on small variations in the original experiment. However, this issue is alleviated with the line charge model, as the charges are distributed and are no longer dependent on one single value. There's more that goes into it. Due to experimental error, I got a pretty significantly different result. And additionally, the line charge model is more physically accurate. So I'm going to say that the line charge model is probably a more accurate depiction of the results. Thank you, and peace out.